Hello everyone. Now we are going to solve your question number 6b. In question number 6b, we have given a vector function a and we have to calculate the line integral a dot dr from 0, 0, 0 to 1, 1 along the paths. Okay. So first we will try with first path. So what we are given is uh, the path is here x is equal to t, y is equal to t square and z is equal to t cube. Now, such questions are of very basic level questions. So first we will do a dot dr, which is nothing but 3x square plus 6y dx minus 14yz dy plus 20xz square dz. Okay. Now limits, we put the limit of t will run from 0 to 1. Okay, so we can put 3t square plus 6t square dx is your dt minus 14 y is your t square, y z is your t cube, and dy is your 2t dt plus 20x is your t and z is your t cube. So t cube, that z square will be t to the power 6 and differentiation of dz is 3t square dt. Okay, so this is what. So a dot dr can be written as 0 to 1 9t square, okay, minus of 28 t to the power 5 plus 1 t to the power 6 plus 60 t to the power 8 plus 1 9. Okay, now we can integrate this. This is your 9 minus 28 t to the power 7 by 7 plus 60 t to the power 10 by 10. So this term comes as 3 minus 4 plus 6. So this is 9 minus 4, that is your 5. So in the first case our answer is 5. Okay, now we move for the second case, which says that straight line joining, okay, 0, 0, 0 to 1, 0, 0, okay, and then to 1, 1, 0, and then to 1, 1, 1. So that is the thing. So we will plot this. Okay, now if this is my origin 0, 0, 0, and if I call this as x-axis, this is y and z, so this is my 1, 0, 0, and this one I call as 1, 1, 0, and I take a projection. So this is my 1, 1, 1. Okay, 3 points are there. So if I call this my point P, Q, and R, and this is your origin. Okay, so what is the path? Path is OP, then PQ, and then QR. So we have to compute the line integral along this path. So first of all, we want a dot dr, which is nothing but 3x square plus 6y dx minus 14yz dy plus 20xz square dz. Now I am interested in computing my line integral along OP first. So we'll see. On OP, x varies from 0 to 1 and y and z are 0. So if I call along this path OP, this integral I1, then x runs from 0 to 1 and dy is equal to 0 and dz is equal to 0. Okay, so this can be written as 3x square. This is your 0 dx. This is nothing but x cube. So I get I1 as 1. Similarly, what is on PQ path? You can see over here. On PQ we can see that x is equal to 1 and y runs from 0 to 1. Okay, and z is your 0. So dz is 0, dx is 0. So we are only concerned with the terms of dy. Okay, so this is your y is equal to 1. If I call this as I2, this is minus 14y, okay, into z is your 0 dy. This comes as 0. Okay, now we want along PQ we have done. Now the last part is your along QR. Along QR you can see that x is equal to 1, y is equal to 1 and z runs from 0 to 1. So we are going to use this along QR. 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 This can be written as z is equal to 0 to 1 and y is equal to 1, uh, x is equal to 1. So dy is equal to 0 and dz is equal to 0. So we are instead on the last term 20x z square dz. So we can put the value of x, that is 1. So this is nothing but 20 z cube by 3. So this is 20 by 3. So I3 is 20 by 3. So summing up all the line integrals 1, 0, 20 by 3. This is your 3, 23 by 3. Now you can see answers are coming out to be different. In the first case it was 5. In the second case it is 23 by 3. Now we come to the last part. That is your along 0, 0 to 1, 1, 1. So these are the lines. So if you can write equation of line 1 minus 0 z minus 0, and if I call as value, so I am just parameterizing it. So x, y and z are equal, x, y and z are equal and they are equal to u. And you can very easily see the limits of u runs from 0 to 1. Okay, now we first again we are going to use a dot dr. It is your 3x square plus 6y dx minus 14y z dy plus 20x z square dz. Okay, so we can just parameterize it 0 to 1. This is 3 u square plus 6u du minus 14 u square du plus 20 u cube du. Okay, now this can be written as 3 minus 14 is minus 11 u square plus 6u plus 20u cube d. Now you can integrate this 6 plus, so minus 11 by 3 plus 3, and this is your 5. So 8 minus 11 by 3, 24 minus 11, and this is nothing but 13 by 3. So we are seeing that in all of these three cases answers are different, and that's what they are asking. Is the result same? No, results are not same in all cases. And then they have asked what is the reason. Now we have already said that uh, when until unless the vector field is conservative field, that is its path independent. Okay, so whichever path you will take, it will be conservative field. So for that it has to be a perfect differential, and you can see it's not perfect differential. A dot dr is not a perfect differential. One way of looking at it is that is not perfect differential. Perfect differential, we will look into it. If we can club a dot dr, and we can see this is your 3x square plus 6y dx minus 14yz dy plus 20x z squared dz. Now there are 1 2 3 4 terms, so we can see this we can separate, that's not a problem. This also is not done. Okay, so we can see over here that even if I deal with this, so there are terms like if I take z common here, so 14y dy plus minus 20 xz dy. So there is a relation between z, x and y. So we can see that a dot dr is not a perfect differential. Okay, so that's why we can say that answers are not same. Another way of looking at it, that when it is so, when the curl of a has to be 0 for perfect differential or for conservative field. You can always look up whether you are doing partial differential equation questions, vector or ordinary differential equation. So you can always check up for their perfect differentiability. So here that's the case. So in this case it will turn out to be not 0. So we can write this as I j k dou by dou x dou by dou y dou by dou z, and I write the terms 3x square plus 6y minus 14yz and 20x z square. So this is 0, and this part is your minus 14 into y. Minus minus become plus. Similarly for this part, this is your how much? 20 z square plus k. This is 0 and minus of 6y. So we can see that the curl of A doesn't come as 0. Okay, so this, hence we can say it is path dependent, not conservative vector function, and hence the answers are different in all the different cases. So this fundamental concept, they will ask either work done for a conservative field. Okay, sometimes they'll ask you scalar potential. So these questions are very predictable questions, and these are one of the easiest question. So you can like and share, and this will help us to do more on our part and have an interactive approach so that we can reach out to you and vice versa. Thank you once again.